So we're going to see about the recap of the BJT. Okay. So short recap about the BJT. Okay, BJT. Okay. First point BJT. If I have see that a BJT, it consists of three terminals. Okay, it consists of three terminals. What are the terminals? Mean base, collector, and emitter. This is the three terminals. Next one is what are the configurations? So configuration. So configuration wise, so it has that one. What are the configuration means? So common. So common will come on that these three terminal in front of common base, common collector, and a common emitter. Common emitter means what? What is this common? Common for particularly. So for example, we're going to take amplification. So amplification, which one configuration is suitable? Which one configuration is good? Effective. If you are going to ask the question, common emitter is a suitable one. Okay, what is meaning of the common? So common means, so it is a common for, okay, common for input as well as output, input and output. So which one is common? Emitter. So emitter is common, that is the meaning. So emitter is a common for input and output, that is called a common. So emitter is a common for input and output, that's why it is a common emitter. Okay, so it is like it is calling. Okay, particularly amplification. So amplification means op-amp. So very I mean famous oldest op-amp is we are going to use. Okay, that is called a 741 IC. Okay, that one it is used to, what is the purpose? So it is used to, you will going to for sine wave generation, square wave, and the triangular wave. So that okay, triangular wave you will going to generate it, and further you will go for the comparator. So you will going to compare the two signals, you will do for that one. And further zero crossing detector, and for the segmented trigger, closed loop op-amp, segmented trigger, SCHEMIT, segmented trigger, closed loop op-amp. Okay, further you will going to see about the peak detector, and instrument amplifier means what? Instrument amplifier means pandemic situation, they will going to find the temperature of the human body. How do they will going to find out the temperature of the human body? Okay, so they will going to use one handhold type of the instrument. Okay, they will going to pass the rays, and they will going to find that what is the temperatures. Okay, the temperature will go to the display. So the sensor it will going to, okay, sense the temperature and display, that is called instrumentation amplifier. And I to V converter. So V converters, so I to V. So I to V means it's a photovoltaic panel is a current phenomena. That current phenomena I need to store for that entire day means that is called I to V converter. And V to I converters, okay, long, okay, I need to pass my signal on the long distance, etc. So these are the these are the op-amp if you want to develop. So op-amp only is it possible for that amplification means? No. So what is other devices, BJT and FET also it is a possible for that amplification purpose. So these two also it is a do. Okay, how if you want to do for that one amplification for the BJT means you will going to use, okay, use for the common emitter you will going to use, common emitter you can use for that one. Okay, if I have see that one, that a developer device is called class A. Class A, you will going to say it is simply, it is a as a class A, that's all. So class A. Yes, so this is a circuit diagram. So see here is a emitter is common. This is a emitter, base, collector, emitter. Emitter is common for input as well as output. Okay, input as well as output. Okay, then yeah. So what we are discussed, class A. So class A means nothing but this is a class A. See that one, this is a class A, base, collector, emitter. Emitter is a common for input as well as output. So this is a, so further resistance we are added on the base side. Okay, another one is a load side, output side. Another one is a bypass of that capacitors. Okay, like you will going to use this is a biasing. So this base side you are using the resistance is called a bias resistance, bias. Another one is this is a bypass. So bypass capacitance you are using on the emitter side. So this is the output load side, load resistance you can say. So base, collector, emitter. Output is a collector. Here is a input terminal. Okay, here is a capacitance. This is only one. Okay, class A amplifier. The next one you want to know about what is a controlling device. This BJT is a current control device. Current control device means what? So it's a current dependent parameters. So if whatever the here is the input side is vary, the input side is vary means how do you going to vary? Either the voltage or the resistance. So these two used to, you will going to vary the input side. Okay, if I will going to vary the input, what will happen? The current is a flow of current is a vary. So what is the flow of current? 200 microamps. So 300 microamps. So 400 microamps. What is the meaning of that one? Why do I want to increase the current rating? It's nothing but it's a simple for the tap. So tap, particularly push button type of the tap. Yeah, so this is a base, so a base side. Okay, this is a base side. Okay, this is a vary either the source you can going to vary or resistance you can vary. So if you're going to vary means the input flow of the current is vary. So what is the meaning? So for meaning of that, you will going to give for that 100 microamps. And what is the difference for that applying the 500 microamps? What is the difference? 100 microamps you are going to apply, and 500 microamps what is applied? This is a differentiation. That's why this is a picture I have show you. So you know that one, there's a tab. Okay, so in restroom we are going to using under this type of the tab you are using. So when you will go to lightly, I will going to press means what happen? Your water outlet is a very light. So when I will going to press lightly, okay, light press, my, I mean, for example 25% I will go to give the press. Okay, what is my output? Output is only 25%. When I will, that is called 100 microamps. That is called 100 microamps. So what is the meaning for 500 microamps means I will going to give that a full press. So full press means what happen? My output is 100%. That's all. So this is a nothing but here a variation of the current, variation of the current, variation of the push. Okay, so if you are going to give the switch is closed or switch is open, it will go to totally dependent. So it's a current control device. Okay, then okay, if I'm not apply for that any push, so what about my output of the water? No, that is called IB is equal to 0. So no base current is applied, so I'm not push this tap. The output is a no water is coming, that is called the output current is 0. Okay, that is the output current. Okay, what is output characteristics? You will going to see for that output current versus the output voltage. So you will going to draw what is output current, that is called the that is called collector. So collector current versus, so here I will going to write, so collector current versus output voltage. What is output voltage? Collector to emitter. So collector to emitter connected voltage. That's all. So this is called output characteristics. Now you will going to start to draw the curve on that ones. Okay, so I have draw for that output current versus the output voltage. So if I have see that one, so initially linearly increase, after that is saturated. So linearly output current as well as output voltage is increase, and after that output current is maintained as constant. If you are going to increase further, voltage is increase. So this is called output characteristics. Okay, if it is a 200 microamps as an input, okay, 25% push and 50% push and 100% push. So what is that one? See that one sudden increases. This is a high level, linearly up to here it increase, after that is saturated. Okay, like it is a differentiation. Then next one is you will going to draw the load line. How to draw the load line? Load line is connected between the, here is a saturated point and cutoff point. It is connected between the saturated point and the cutoff point. What is saturated point? Saturated point is nothing but on, turn on. Turn on means what you have? Once the switch is closed, across the voltage is 0. Once the switch is closed, across the voltage is 0 only. For example, this a switch is there. Okay, so switch across, you will going to connect your 1 voltmeter. This is a very important question. Okay, particularly in theoretical as well as practically, they will ask you. Okay, so voltmeter is connected across the switch. Okay, that is called VCE. The switch's name is called VCE. Okay, once the switch is closed means, so what is the voltage? So short circuited means close. So close means output is a 0 voltage only. Okay, that's why it's a saturated point. Saturated point. What is meaning? No, this is a point is called a cutoff point. Cutoff point means what? Voltage is there, but output current is 0. So no output current, no, I mean no conduction. That's all. Output current is 0 means no conductions. That's all. Okay, so this is about that one. Okay, next one you will going to draw. How to draw? Find the Q point. Then after find the Q point, join the lines. That's all. So find the Q point. How to find the Q point? Step number 1 and step number 2. There are 2 steps. What is the step number 1? Step number 1 is collector current is equal to gain multiply base current. What is the base current you are going to apply? 200 microamps applied, and the beta is it's a voltage. What is the voltage? 50 voltage. What 50? Where is the 50 voltage? You have see that one. It's a 50 voltage. Source is a 50 voltage. Okay, then you can multiply, you say 10,000 microamps or 10 milliampere, and substitute this one VCE, and you are going to substitute that one IC. What is the VCC voltage? So you have see that one 10 voltage I am apply, then 10 voltage you can substitute, and RC. So RC is what is that one? So here is the RC collector resistance 220 ohm. Yes, you will want to substitute and find that one, subtract, and 7.8. So 10 milliampere, 7.8. So 10 milliamperes, so 7.8. So that is a point, is a Q point of the 200 microamps. Similarly, you will going to increase into the 300 and find the current and substitute to this one and find the voltage. Yes, this is a point. Similarly, this is a increase the 400 microamps. Then after that, joint. That's all. This is about the Q point. So this is a part up to we were discussed. So what are the points so far we are discussed? So Q point we were discussed. So Q point is nothing but a connected between the, so it is a connected, so between, so 2 point, what is that one? Saturate and cut off. Okay, this is a point it will going to, how to find the Q point. So how to, we will going to second next question, how to find Q point? Yes, so there are two formula. One is called collector current. So collector current, it is equal to gain multiply, okay, that is called sorry, what is input current, base current, okay, base current multiply with that one, okay, input voltage or beta, gain voltage. So input voltage you will going to use to find out, and after that one more formula you will going to find out for that VCC. So you will going to need it for that VCC and IC. So if you have no, then you will going to find the Q point. That's all. And further else what we were discussed. So we were discussed about output characteristics. We were discussed output characteristics. What is output characteristics? Output current versus the output voltage. So BJT, what is output current? BJT output current is a collector current versus the VCE voltage. Okay, that is the output characteristics. So this is a point we were discussed. Okay, and then class A. Okay, class A configuration. What is the class A configuration? So class A configurations, this is a class A configurations. Input side, okay, base side you are using the 2 resistance, it's a bias, and then this is a collector side, so you are using it with load resistance, it is a bypass. Okay, emitter side you are using bypass capacitance. Okay, so this is about the input and then output of the waveform. So from the Q point you will going to extract it. That's all.